Okay, wir fangen einfach mal an. Ja, schön, dass ihr alle hier seid. Wir machen das Ganze jetzt ohne den Live-Chat auf entwickler.de, weil die Seite nicht erreichbar ist, deswegen auch die Verspätung. Sorry dafür. Ja, genau. Da der Chat wegfällt, falls er jetzt nicht im Laufe des Vortrags erreichbar ist, machen wir am Ende einfach hier eine kleine Fragerunde und ich würde dann mit dem Mikrofon rumgehen, sodass Lothar das auch hören kann. Genau. Dann gebe ich das Wort mal an dich weiter.
Vielen Dank. This call was and this presentation was scheduled in English, so I'm gonna use the opportunity to talk English to you. In case there are only Germans in the room, I'm also happy to switch to German, but I do not know the audience in the room, and I also do not know who is online, so by default it's gonna be English. Hello from Berlin. My name is Lothar, and today I want to share some details about Java sealed classes and Kotlin sealed classes. Before I start with that, 2 or 3 sentences about myself. I work with software engineers as head of engineering. We all work from Miro.com, online whiteboarding. Check it out in case you don't know it yet. It's really cool. And in my spare time, I do things like this. You find me on some social media. And if you are interested in those very small slide deck, please scan the barcode now. I leave the slide online for a couple of more seconds so you can scan the barcode. And in case you don't have your smartphone ready at the moment, there will be also the barcode at the end of this very small slide deck, and then you can scan it a second time. So let's talk about the actual topic. Java sealed classes versus Kotlin sealed classes. Why did I choose this topic? I like coding with Kotlin. I like coding with sealed classes and data classes in Kotlin, and the latest JDK 17, the latest LTS, provided sealed classes for Java as a feature. So it has been available since 15 as a preview, but since 17 it's a feature, and that caught my attention, and I wanted to learn, like, what is the difference? How does it feel like in comparison? And today I want to share what I learned and how it feels for me. And in case you are in the situation where using of sealed classes in Java or Kotlin is very important for your project, then you may use the approaches that I used and may lean to one of those sites. What are now Java sealed classes in a very condensed and in a nutshell version? So in Java, sealing allows classes and interfaces to define their permitted subtypes. And earlier you couldn't really do that. Now you can do that, and it works like you define a sealed class. In this slide example, it could be connection, and you use the sealed keyword to identify this class as a sealed class, and then you use the permits keyword to tell the compiler the following classes are the ones that connection permits. So those are the permitted subtypes. And the permitted subtypes in this example can be a final class. And once you define the final class, you have to also tell the compiler this final class is going to be extended by the sealed class, which is in this case connection. And in Java, you need to be aware of constraints that come with those sealed classes. Sorry, the constraints for subclasses that comes with the usage with sealed classes. First of all, they all have to be in the same module as the sealed class. Second, you saw that before, the extend keyword has to be explicitly used. So in the sealed class definition, you say you define with the permits keyword the subclasses, and in the subclass definition, you use the extend keyword to to define the parent class. And also the subclasses, they have to use one of the modifiers final, sealed, or non-sealed. That was very high level and condensed Java sealed classes. And before we start with a lot of code, two more slides about Kotlin sealed classes. Whenever I think of Kotlin sealed classes, to me, those are super enums. Why there are super in my mind? With sealed classes in Kotlin, you can save state in the subclasses, which are often data classes. And those data classes that are more or less containers for your data, they can be almost of any type. So that makes it really flexible, and that's one notion of super to me. The more official definition I found online was that you'll define and fix type hierarchies, and you can forbid other developers from creating new subclasses. How does that look like in some code notion? So you would define a sealed class with the sealed keyword similar to the Java part. And within the class definition in Kotlin, you would define data classes that would be then per data class containers for your data. Sealed classes exist since Kotlin 1.3. Interfaces have been introduced in 1.5. And 1.5 is also the version I use in my code. And 17, Java 17, JDK 17 is the underlying JDK version. And now, as promised, one more time, the QR code. So for all of you who would like to scan the QR code, please do that now. The code that I'm gonna share with you in a second is also available on GitHub. Once you downloaded this Miro board as slides, you can click on this repository link, and that brings you to the GitHub repository. And in that repository, you'll find all the code that you will also see in a second. All right, enough of slide kind of things, because now we go slideless. I have some Kotlin code. I want to start with showing you some Kotlin code and how sealed classes can be used here. What does this code do? This code takes as input a GitHub organization and a access token for this organization. And with those two information, it reads the repository of that organization in case repositories exist. And I hope it's gonna work right now. So I'm gonna build the code, and also afterwards we'll start. So the building worked, and also reading the 4 repositories that exist in this organization was successful. So this is not important for the code, but this is building the code. This is starting the actual jar file that was just built. And then there is a parameter that identifies the organization that shall be scanned. The personal access token that identifies myself with the GitHub platform is a environment parameter, because I don't want to expose that to you. And in case you want to use the code yourself, then you would have to create your own personal access token. Now about the code and where I believe the code could be improved. Please have a look on this function which verifies the GitHub organization. So what the function does is it shall return a instance of GH organization. GH organization is a class that is part of the GitHub API library that has been originally started by KK, who also started Jenkins CI server. And that is, I believe, one of the most used libraries whenever you want to access the API, the GitHub API. And you can ask this library, and specifically the get organization method from that library, to get you an instance of the GitHub organization. And this call, get me the organization, can throw an exception, in this case, an IO exception. And in case the IO exception is thrown, the function returns null. And in case there is no exception and everything works as expected, the return value and the return instance is of type GH organization. In Kotlin, this is, I use as a return value this nullable type, which in a nutshell says it can be null or it can contain some information. And what I don't like about this code is that I return null here. And this is what I try to improve. And before that, let's check how this function gets used in another function. So in this, let me increase the font size a bit. I hope that is readable. So here we call that function I just explained to you. The return value is a value, or I called it GitHub organization. And if that GitHub organization value is not null, so I'm gonna do a save call here. If it's not null, then I use that value and ask to list all the repositories, and then I print out the repositories, and the result is what you saw down here. Now we change that function, and the way we use that will change, as well as this function will change. The way I want that to change is, of course, to use sealed classes to show you how that would work. So I'm going to start with a new Kotlin class. And that class, I call that organization. Okay. And whenever I code, let me increase the font size. You know, I don't code anything from the very scratch. I think you do the same. I use other code that I used before. So I hope that would help to see all the important code at the same time. So here I have an example of a sealed class that I use for a different purpose, and my new sealed class will have the same structure. So I just use that to be inspired, or you could also say to read from what I defined before. So I use the sealed keyword to say this organization is now a sealed class, and within that sealed class I want to hold some data, and for that I use a data, not one but multiple data classes. And similar to the example below, there is the case when reading the organization is a success, and in that case I want to have the organization that the library gives back to me is hold into a variable. So I'm going to define a container for that GitHub organization once it exists. And in order to be compliant with the compiler requirements, I'm going to refer to the default constructor of the sealed class. And I also take care about the failure case. And the failure case will hopefully share with me a reason why an error or a failure happened. So I'm going to define an error string. And that error string will save the data why something went wrong. Now I have a sealed class with some data containers where I can store some data. And how would that now work with the method that's implementation I don't like and that I want to share? So instead of returning this nullable type GH organization, if I can read the organization, I would return a organization with a success data class. And the success data class needs the value of the GH organization, like the actual instance of the organization provided by the library. And that value is what I get already in the call that I commented out. Now the compiler is not happy because the return value does not match with the footprint of the function. So I'm going to change the footprint of the function, and I tell the function now you return a sealed class instance of type organization. And again, the compiler is not happy because this line says I'm going to return null, but the sealed class does not have any notion of a null, any definition of how null would be look like. And for that case, I created the failure data class. And the failure data class is about the fact that some error happened and we would like to know about the error. We would like to fetch the error. And the error is represented in an IO exception. And we can ask the IO exception for the localized message. And now I argue that this function looks way better. We have now no null anymore. We do handle the IO exception case with a specific data class that we defined for that. And we have one return value, which is not a nullable type anymore, but it's a sealed class. And we have defined data classes that determine which cases we'll have to handle. Now, those cases that we'll have to handle, there are important when we call that function. And calling the function is in the original code here. And the compiler is not happy with this it keyword because this it, the way it's implemented, refers to GH organization instance, which is the one coming from the library. But I just changed the footprint of the function, and the return value is now of type organization, the sealed class organization. And this is what I have to deal with now. And what we can do is that this whole code that deals with nulls, we'll leave that out. We'll start from scratch, and I go like, when I have the value which is labeled GitHub organization, I can ask what type is this value like. And there are two options. Option number one is it's organization success. So then I know I was able to read the organization, and the organization exists, and I can use that instance further. And I can also take care about the else case. Now, this is one option to implement that. And I argue this smells. I believe this is not good because imagine we would define down here additional data classes, whatever it is, right? And we would define some value that would hold additional data, like so. If we do if I do the pattern matching using when with the else branch, then those two data classes would be called. And whenever we add additional data, or I add additional data classes to the sealed class, they would be all called in that branch. And I believe this is smell. I believe developers should be explicit about the cases they want to handle. And that's why I argue, so this must be an explicit state. And we need to explicitly handle the failure case. Let me remove the something data class because this was just for showcase. And now we have in the success state the situation that we want to do exactly what has been done before. So I'm just copy the code that was there. And GitHub organization has now a container that I can use, which is GH organization. It's exactly this container that I defined here. And this organization handle is used by the list org repos function. And then I have a list of repositories, ideally, if there are any repositories. And if the list is not empty, then every repository gets printed out. And in the failure case, we know there is a failure, and just for this sample code, we would just print out the failure, and we would just say something like this. Now the code should compile. There is still one hint that I'm happy to follow because IntelliJ tells me to move the variable declaration into the when. So that saves one line of code. I ask yourself if you believe this is better readable than that. I think there is no real difference. I think it's a matter of taste. So I keep it like this. Let me remove the commented code. And let's double check here if there is something to remove. No, that looks good. Then let's try if the code still works. I use here Gradle W clean by purpose because I want to make sure it's really the code that I just changed to be built and then also to be called, and hopefully it works. So building looks good and fetching the data from the API looks also good. So that's exactly the same result that we had before. So this was Kotlin. Just to recap, sealed class with a sealed keyword, data classes. In case the list of values that you put in the default constructor is not long, you can do that with a one-liner. Let's look at how this looks in Java. This Java project does, from a functional point of view, exactly the same what you've seen before. So I try to run this, and I hope it works. So it builds a jar file, and this jar file gets called and asks the GitHub API for the repositories of that organization, and it's exactly the same result, luckily. And here I have a similar situation. So there is a method, in this case a static method, and that lists repositories. So you saw that in the Kotlin code before. Once this organization exists, there was a function in Kotlin that lists the repositories, and then the list of repositories is printed out. This method is listing the repositories, and it is it smells similar to the original code I showed you in in Kotlin. So if listing the repository is a success, then a list of the repositories gets returned. However, if an exception happens, then null is returned. And because null is returned, I believe that's why the code smells. Let's look at how the code gets called. So the code is called, and the list of GH repository is in the variable repos. And if repos is not null, then there is a for each loop and prints out the repositories that you just saw. And I believe this can be improved, and this can be changed using sealed classes. In Java sealed classes, in the first iteration of the new code, there will be at least 3 classes, and for visibility reasons, I'm gonna create a new package for that, and I call it repository. And in that new package, I create all the new files that I need. And the first file that I need is a Java class, which is a GitHub repository. And now let me order the code in a way that hopefully you can see that well. And also, I do not only create a sealed, it's gonna be a sealed class, it's not a sealed class yet, a sealed class for GitHub repository. I create a final class that is for the success case, and a final class for the failure case, similar to the Kotlin example. All right, so let's make that a little bit bigger so you can see the code better. Okay. And as before, now it's big enough. As before, I am lazy. I'm using some code that I wrote before, and I use this as inspiration, like so. All right. So let's order that a bit. Now I think it's hopefully the font size is hopefully sufficient for me. So first, it's a sealed class. Like so. It's a sealed class. And now this sealed class permits certain subclasses. And the subclasses are those 2 ones that I defined here. So one is for the success, and the other one is for the failure case. All right, good. The success case, in the success case, we need some data to work with, and in this case, those data will be the list of GH repositories. So there will be a list, and that list will contain, GH repositories. Okay. And then we need some more. We need a constructor and a getter, and I asked the IDE to help me. So I'm going to show you this once, and then I use the shortcut. So now I have a constructor, and now I'm going to create a getter for these repositories. And this is my class for the success case. And I need to double check. I think it must be final. Yes. So my memory was correct. So that must be a final class. Okay. And now I do the same for the failure case. Sorry for this some boilerplate code. Sorry, in Java we say first what the type is, and then we say what the label is. And now a constructor with the property and a getter with the property. Okay, good. That looks okay. However, what I forgot was to extend the sealed class and also to make it final. And here I forgot to extend the sealed class, and it was final already. Good. And here, at least the IDE is so far happy with the definition. Now let's use this. I think we can close this and move it like so. Now let's use this in the in improving hopefully the code. In the success case will return the success data class. Sorry, not data class, a final class. Let me cheat real quick how that has been done. So I'm going to return a GitHub repository success, and that success requires, that constructor requires the list that is provided by the call to the library function. And now the return value needs to change. And the return value, now I have a, the return value is the sealed class that I defined. And in case an exception happens, I'm gonna return the failure case, repository failure, and similar to the Kotlin example, I use the localized message. Now I need to import the return value, and there is still some issue here. What is the issue like? Utils list repository. Interesting, it doesn't like this. What's wrong here? The new keyword was missing. I'm sorry. Yeah. Now the problem should be gone. Is it gone? Yeah. It's gone in a sense that this implementation is now the way I want it, but there is still a problem with the code that calls that function. And this code is here. So the type of repos obviously changed, right? So the type is now a GitHub repository. So let's change this. And now this code is different. And what is, let's make sure the compiler knows about this. And now, similar to the Kotlin example, I can ask, like, what is the type of repos And depending on the type, I can do certain actions. And in Kotlin, it was when, and in Java, it's if. And if repos has a specific type, in the first case, the type of success, then we shall deal with a success case. And in case it's the failure, then we can deal with the failure case. I made this statement before in when, in pattern matching in Kotlin using when, you should not use the else branch the way I showed you. It's similarly true to in Java, but in a different fashion. So for that sample code, please forgive me if I just use the else branch here, although I know that should be more explicit. So in case there is any issue, oh sorry, this is wrong. I don't want to return an empty list. I just want to say there was an issue, and I want to print that out to the main output. And here I can now use something else. And now I caught myself into some trouble. So it must be more specific. I need to ask for the specific repository failure, because once I ask for the type repository failure, I can give it a label, and using that label, I can refer to the data that are defined here, and I can print out the error that originally came from the exception. Let me show you one more time where this is. So here we catch the exception. We use GitHub repository failure final class to keep the data of the error. And here we use the data that are in the error to print it out to the command line. And in this case, when we have a success, we can just use similar code to iterate over the list and print out the repository name. But we need to do that with the repositories that we have. And again, I can use this label that was introduced with the instance of keyword. I get myself the repositories, and then I loop over the repositories that exist. And now the code should be ready to be called. That looks good. So let's go to the terminal and let's check if that works out. The build looks good and the call to the API looks also good. Okay, that is Java sealed classes. And from my point of view, this is a lot of boilerplate code. I am happy that there is another option that I can show you to reduce the number of code, the number of lines in the code. And in my opinion, it's even more readable. I hope you can agree to that once I show you. So what I do next is, instead of sealed classes, I'm going to use sealed interfaces in Java. And instead of final classes, I use Java records. At least Java records are new in JDK 17. Sealed interfaces, I'm maybe also, I'm not 100% sure, but I think it was also in 17. So let's get started. So this sealed class is now an interface. And we have those subclasses, which are not final classes anymore, but those are records. And because I defined an interface. It's not extending, but it's implementing. And similar to the Kotlin code, you can define the data container that you use for the data that you want to deal with in your records in a default constructor-like statement like so. And now all the boilerplate code that has been generated can be removed. So that looks promising. And also the IDE is happy with that code. So let's apply the same approach to the failure case. Record, implements, and the error is hold here, and all the boilerplate code goes away. All right, that looks also good. Now the interface, at least the IDE says no error in this code anymore. And now let's double check the other code that I adapted before. So we have some issues here, and I'll come to them in a minute. Before, I want to show you that the initial method that I wanted to change, list repositories, that had here returning null, does not change. So in using public final classes that are used in sealed classes in Java, the records and the return value as sealed interface does not change a thing. So it's exactly the same code. I don't need to change anything. What is different though is in the records, there is implicitly getters and also setters, and those have different naming schemes than the code that has been generated by IntelliJ for me. So the getter is not get repositories anymore. The getter is repositories. So I just get me the repositories with a different method call, and then it prints out ideally the repositories that exist in the organization in question. And now I also get the error in the error case like so. That looks promising. At least the IDE tells me no errors. So let's build the code one more time, clean, and check if the call to the API works. Code building looks good, was successful, and also the result is the same. That's it with the code. That is all the live coding that I prepared for today. Before we start before I'm happy to listen to your questions, let me repeat what I believe is can be some guidance for you. So what I see as pro argument, in case you want to go the Kotlin way with sealed classes, is you can put the sealed classes as one-liners inline into your Kotlin sealed class definition. That makes that code very compact. And another pro that I see is that pattern matching using when in Kotlin with the is keyword is feels very natural, feels very functional like. In Java, I ask you to consider sealed interfaces, because the interface definition is also can be a one-liner, just like so. And the record, and I ask you to consider records instead of final classes, because then you save a lot of boilerplate code, and you can use a similar constructor-like way to define your data containers. What is in this example, the records are with different files, which could be hopefully also improved to make it into one file to make it more readable. And there is another thing which I ask you to consider when you work with Java sealed classes, interfaces, records, or final subclasses. When you do pattern matching like using if and instance of, use the labeling mechanism that is an option for you, because once you have that you define that label, you have a handle on the actual record or final subclass, and you can then refer to the data containers that you defined. Without that label, you have to create additional boilerplate code to get to those data containers, and this is I really like that way the instance of operator has been improved in Java. And now I'm happy to listen to your questions. I'm sure you have questions, and in the meantime I put the QR code on the screen so you can scan the code in case you didn't have the chance to scan it. Are there any questions?
Thank you for your presentation, Lothar. I think there are no questions. And sorry for starting in German. I didn't know that. Because
no worries. No worries.
Okay. I also like to ask you to give a feedback if the site is working again at entwickler.de for Lothar, and also for all the other talks you were listening to. Yeah. And I think that's it.
Thanks for having me. Enjoy the rest of the conference. Send my regards from Berlin.